Hello, I'm Dr. Harper. This video is in a Management of Operations, an exam study guide. So let's bring up the notes. First of all, the exam's summary information is the exam will be online, multiple choice, timed, open book, and open notes. No collaboration and no internet. No internet as far as getting information from other sources other than the information in the course. Each student must take their own exam. Exams will be over 4 topics, 20 multiple choice questions, 2 points per question, 60 minutes. The exam is designed for evaluation. No exam accepted after the end of the course. General information. Online examinations designed for evaluation will be given in this course. The exam may be taken only once. The exam will be open book, open notes, and timed. No collaboration is allowed. Collaboration is cheating. No communication with any outside agent is allowed. And that's another student, another person, or even some virtual person. It's just all your information that you've gained from the course. No sharing of material or equipment is allowed. If academic dishonesty occurs on an exam, the student will receive a 0 for the exam. Any incident of academic dishonesty may be reported to the Internal Affairs Committee of the Business School at the University of Colorado Denver for further action. Answers to the exam will be posted online. Exam grades will be posted on Canvas. Course grades will be reported to the registrar and will not be posted on Canvas. Okay, so now the exam design. First of all, exam questions will be approximately distributed over 4 topics: forecasting, linear programming, aggregate planning, and inventory, with approximately 5 questions per topic. I say approximately here because sometimes questions could apply to more than one topic. Exam study guide. For each question, this guide will describe the material and the type of question that will be asked. Since the exam is open book and open notes, purposes of this study guide are not only to review the material, but also to know where to find the material for the answers in your notes. Some questions will be qualitative and some will be quantitative. Therefore, a calculator will be helpful. I say a calculator will be helpful, but Excel, a computer is not necessary. It's just arithmetic in different places, and you'll see where in just a second. Also, the wording and values in the actual exam questions can vary from this guide. Actually, they will vary from the guide. I don't use the same numbers. Okay, let's start. Topic 1, forecasting, 5 questions. Question 1 is based on the relationship between the components existing in the time series and the preferred forecasting technique. In here, I'm just matching them up. A random component is matched with moving average exponential smoothing, random and trend, regression, random and seasonal indexes. So I quote a problem and say, which technique would you use? Question 2 is based on the mechanics of the relationships. A seasonal forecast equals seasonally adjusted forecast times a seasonal index. Now I have the forecast in here. I could have said seasonal value equals a seasonally adjusted value times the seasonal index. It's all going to be the same. It would be the same mechanics, and the question could be posed that way. For example, given 2 things, I ask for the third. Given the adjusted and the forecast, I ask for the index. Given the index and the forecast, I ask for the adjusted forecast. In other words, I give you 2 and ask for the third. And there will be actual values, actual numbers. Okay, question 3. Question 3 is based on the mechanics of moving average with a window identified. For example, in the time series 2, 4, 6, 8 for years 1, 2, 3, 4 respectively, the forecast for year 5 using a moving average with a window of 2 is you average the last 2 values, which is 7. So that's going to be a numerical quantitative question, and it's nothing more than just taking a moving average. Question 4 is based on a stationary quarterly time series with only seasonal and random components. For example, given something like this, and I will give you a table just like this with different numbers. But the possible questions from the table is, what's the seasonal forecast for quarter 2 of year 3? Well, since this is a sum, it's 260 over 2. Since there's two of these and it's 260, it's 260 over 2, which is 130. The seasonally adjusted forecast for quarter 3, well, it's 800 divided by the number in the sum, which is 8. 800 divided by 8 is 100. The seasonal index for quarter 4, well, it's going to be the average of this, 20 over 2, divided by the average of everything, 800 over 8, which would be 0.1. So it'll be one of these questions. Question 5. Based on a non-stationary quarterly time series with only seasonal, random, and linear trend components, for example, again, I will give you a table and ask for the seasonal forecast for one of the quarters. And since there's only two here, this 65 and 95, since the trend then will be 195 minus 65, that's the trend. You add that to 195 and you get your forecast. I'm just keep it simple as just two. There's no regression, it's just observing the trend. Okay, topic 2 is linear programming, 5 questions. Question 1 is based on the type of LP defined. For example, a product mix, an ingredient mix, transportation. It'll be one of those. I'll be describing one of those with a problem, and you say, oh, this is a product mix problem. Question 2 is based on the definitions and mechanics of an LP formulation. For example, in the LP, recognize it that this is the objective function. This is greater than, so there'll be a surplus for that constraint, and this is less than, so there'll be a slack for this constraint, and I give you a mix, an x and y. Okay, the slack is 9, the surplus is 10, the value of the objective function is 11. In essence, you have to take these and put them in there. For the slack, recognizing the slack is here, that's this equation. And so 35 minus 8 plus 9 is 17. 35 minus 17 is 9. Just a calculator is all you need. For surplus, it's greater than here. So this is 2 times 9 is 18, plus 8 is 26. 26 from 35 is 9. And then you say 1 and 2. So this is 5 plus 12 is 17. That's 10 greater than 7. The objective function is 3 times 1 and 4 times 2 here. 8 plus 3 is 11. So actually, I'll just do one of these. I won't do all three of them. And so I'll give you, in this question, I'll say, in this LP, what is the slack? What is the surplus? What is the value of the objective function? I'll give you one of those. Okay, question 3 is based on the definition of mechanics related to the objective function. For example, in the product mix, and I'll give you a table just like this with different numbers, and I give you a value for A and a value for B, that's the product mix, A and B. I say, what's the profit? Well, it's 2 times 7 plus 3 times 4, which is 26. Question 4 is based on the definition of mechanics related to the slack of a constraint. Again, I'll give you a table much like this with different numbers. And then I'll say, okay, for this mix, A is 7 and B is 4. What is the slack of X? What's the slack of Y? What's the slack of Z? And you have to go through and say 24 minus. So right up here, if A equals 7 and B equals 4, and then you go through and say here's 16 plus 7 is 24 minus that. So that'll be a 1. Well, here's 44, 16 plus 7, so it's 23 is 1 from 24. Here's 20 plus 14 is 34, and that's 2 from 36. Here's 24 and 21, that's 45, and that's 3 from 48. Okay, question 5, based on the definition of mechanics related to the binding constraint. I do the same thing, but then I say which constraint is binding. And the one that's binding is the one with 0 slack. And so it's similar to the other one, except I give you a mix. I give you the, right here, And actually, even though I don't say it here, I'll just want to tell you what I'll do. I'll make one of these 0 so that one of them will go away. Okay, just to make it easy. Either this one, B is 0 or A is 0, I vary it. But that way you're just working with one to say, so if this is 4 times 4 is 16, that's not equal to, suppose A is 0. Then suppose A was 0 and B was 4. Well, let's see. Let's say B was 7. 4 times 7 is 28. Well, that's infeasible. 5 times 35. Well, that one's going to be binding. 6 to 42. Well, that's non-binding. In other words, I'll do the 0 thing. For this one, though, I went 7 and 4. With 7 and 4, you can say the one with the slack of 0, that's the one that's binding. See? Okay. Topic 3 is aggregate planning, 5 questions. The qualitative here, the question 1 is based on the relationship between the pure strategies of level and chase, the variability in demand, and control over inventory and labor. Possible questions, and I'll ask one of these. The inventory is independent of demand variability for a pure chase strategy. The labor is independent of demand variability for a pure level strategy. Another way to say it is a pure chase strategy results in the most control over inventory. A pure level strategy results in the most control over labor. And sometimes I will ask just one of these down here. Sometimes I'll combine these up here with these down here. But question 1 will be about that. Question 2 is based on the relationship of production standard, and FTE requirements, specifically the equation, the number of FTEs given the production standard, where the production standard is given. In other words, I'll say, how many FTEs do you need? Okay, for example, find the FTEs required given a production standard and a production level. For a production standard of 200 items per year, 2 annual FTEs are required to produce an annual production of 400 items. In other words, I'll ask how many FTEs are required. Now, question 3 is similar, based on the recognition of quarterly production standard from the quarterly demand and quarterly production for the year. So in this case, specifically determining the production standard. It's doing it the other way. For example, a production standard of 1 FTE equals 200 items per quarter, and a quarterly production of 400 items requires 2 quarterly FTEs. So in other words, I give you these two and ask for the production standard. Now, question 4 is based on recognizing the type of aggregate planning strategy from the quarterly demand and quarterly production where an inventory objective is introduced. For example, consider a quarterly demand of 4682 for quarters 1, 2, 3, 4 respectively, where the annual demand is 20. Well, 4 plus 6 is 10, 8 plus 2 is 10, 10 and 10 is 20. A level strategy would result in a quarterly production of 5555, since 5 is the average. A chase demand strategy would result in a quarterly production of 4682, since production equals demand. Any other production plan would be a mixed strategy. Now suppose an annual inventory objective of an increase of 4 was introduced. Since an annual inventory objective of 4 results in a quarterly inventory objective of 1, if it's 4 for the year, then it's 1 for the quarter. 1, 1, 1, 1. The quarterly production is increased by 1 to achieve an annual inventory objective of 4. Therefore, the level strategy of 5555 will be 6666. The chase strategy of 4682 will be 5793. Any other production plan that achieves the annual inventory objective of 4 for the year is a mixed plan. So for this question, I will ask you something down in here. One of these. I'll give you an inventory objective. I'll say it's level or is it level or chase? If it is level or chase, then it's going to be one of these for this problem. So I will give you one down here. Now, question 5 is based on recognizing the relationship between aggregate planning strategies and costs. Specifically, the way level and chase strategies will result in labor cost of hiring and firing and inventory carrying cost. In other words, essentially I'll be asking, based on the relationship, to recognize that chase demand will have no hiring and firing cost. Just the other way. Level capacity will have no hiring and firing cost. And chase demand is used, theoretically, to have zero carrying cost. So if you want a zero carrying cost, you'd have to chase demand. So specifically, those are the questions I'll be asking. Okay, topic 4 is inventory. And there are 5 questions. In question 1, this is based on the relationship between the ordering cost, the total ordering cost, total carrying cost, and the inventory policy ROPQ. For constant demand as represented in this graph. So here, notice this line here is the total carrying cost. This line here is the total ordering cost. When we add these together, we get the total inventory cost. But this question 1, is going to be based on the relationship of the ordering and carrying cost depending on your lot size and what EOQ is. In other words, if Q is less than EOQ, if Q is down here and EOQ is up here, and I'll be giving you a Q and an EOQ, I'll be giving you both of those. So if Q is less than EOQ, then the ordering cost is greater than the carrying cost. If Q here is greater than EOQ, then the carrying cost is greater than the ordering cost. Right here. If Q equals EOQ, then they're going to be equal. Everything is equal for a zero safety stock. For a safety stock is 0. So that's what I'll be giving you. One of those. Question 2 is based on the cause and effect changes due to the safety stock in these equations. Okay, in other words, if I say the safety stock changes, notice I say if your safety stock changes, then how does that change the Q? How does it change the D, the T? Does it change the mean? Does it change the lead time? Or if your safety stock changes, is it going to change ROP? Okay, that's all I'm asking. In other words, changing safety stock, what does it change in here? Q, T, the inventory period, the lead time, or their ROP. Question 3, based on the knowledge of the conditions that indicate the application of a base stock level inventory policy. For example, understanding when the base stock level is used and how it's used. For example, is it continuous or periodic? Is it constant or stochastic? In other words, when do you use? What conditions exist such that you use a base stock level? In other words, do you know if it's for continuous or periodic? Do you know if it's for constant demand or stochastic demand? That's all I'm asking on question number 3. Just know when the base stock level is used. Question 4 is based on cause and effect changes in the inventory policy due to changes in these equations. Okay, now on this one, I'm saying, okay, I'm giving you numbers. I'm saying, okay, if the lead time changes, if everything remains constant except the lead time changes, then how does that change the inventory policy? If everything is constant except the variability changes, how does that change the inventory policy? If everything but the mean, how does it change the inventory policy? If the lead time or the team, so I pick one of these. I say everything is constant, but I change one thing in this menu here, and say how does that change the inventory policy? So be aware of how it's going to change the inventory policy. Question 5. is based on the relationship between the stockout level, service level, and the statistical safety stock for stochastic demand continuous review inventory models. And I'll say, for a stochastic demand continuous review inventory policy, then blah, blah, blah. Specifically, the stockout levels are inversely related to service levels, and stockout levels are inversely related to statistical safety stock. In other words, what I'm going to be saying on this one, what I'm going to be asking you different questions. Well, ask you a question, but the type of questions are, if the stockout level increases, then what happens to the safety stock? If the service level increases, what happens to safety stock? Do you order earlier? Do you order later? What happens to ROP? If your stockout level goes up or if your service level goes up, then what does that do to the safety stock? What does that do to the ROP? And do you order earlier or later? Those are the questions I'm asking on this one. So there's three things. One, the increase and decrease of your service level or stockout level. Two, what does it do to the safety stock? What does it do to ROP? And what does it do to ordering earlier or ordering later? Okay, and that's those questions. So come in prepared. You can use all your notes. It's open book, open notes here. If you notice, it is open book, open notes, and this review guide certainly is notes. And you can certainly use this. Hopefully you'll use this to help studying and preparing for the exam. And that's all I have for the exam study guide. I hope this helps. And between now and the next time I see you, I want to urge everyone to be safe and take care.